API gateway, load balancer, reverse proxy. If you've ever felt like these terms get used interchangeably or nodded along in a meeting without fully understanding the difference, you're in good company. They all sit between clients and servers. They all forward requests, but they exist for different reasons and solve different problems. Let's walk through each one, what it does, when you need it, and how they work together in real systems. We'll start with reverse proxies because it's the foundational concept. First, what's a regular proxy? A forward proxy. A forward proxy sits in front of clients. A corporate web proxy that filters which sites employees can visit, or a privacy service that masks your IP address. Those are forward proxies. They help clients reach servers, often while adding a layer of control or anonymity. A reverse proxy is the opposite. It sits in front of servers. When you make a request to most major services, Netflix, Stripe, GitHub, you're not talking directly to their application servers. You're talking to a reverse proxy. It receives your request, forwards it to the appropriate backend, gets the response, and hands it back to you. You never see what's behind it. Why bother with this extra layer? SSL termination. HTTPS encryption is CPU intensive. The proxy handles it so your backend services don't have to. Caching. Store frequently requested responses. 1,000 users requesting the same image, serve it from cache, not from your backend. Security. Your actual servers stay hidden. Attackers only see the proxy's IP. Compression. gzip responses before sending them over the network. Common tools. Nginx, HAProxy, Caddy, Apache. If you've configured any of these in front of an application, you've set up a reverse proxy. The key point, a reverse proxy is general purpose. It doesn't care if it's handling a website, an API, or a WebSocket. It just forwards traffic based on rules you configure. That's useful, but also limited. Which brings us to load balancers. Your application is growing. One server can't keep up, so you add another, then a third. Now you have a new problem. How do requests get distributed across these servers? This is the load balancer's job. A load balancer is a reverse proxy with one specific mission: distribute incoming requests across multiple backends. Two goals: scalability, handle more traffic by adding servers; availability. If one server fails, traffic routes to healthy ones, no downtime for users. How does it decide where to send each request? Algorithms. Round robin. Each server takes turns. Request 1 goes to server A, request 2 to server B, request 3 to server C, then back to A. Simple, works well when servers are identical. Least connections. Send to whichever server is currently handling the fewest requests. Better when some requests take longer than others. IP hash. Same client's IP always routes to the same server. Useful for session stickiness, though stateless architecture is generally a better approach. Weighted. Some servers get more traffic than others, useful when your servers have different capacities. Also, an important distinction: Layer 4 versus Layer 7 load balancing. Layer 4 operates at the TCP level. It sees IP addresses and ports, but doesn't inspect the actual HTTP content. Fast, but limited in routing intelligence. Layer 7 understands HTTP. It can read the URL path, headers, cookies, and route accordingly. All API/users requests to one server pool, API/orders to another. AWS offers both: ALB, Application Load Balancer for Layer 7, NLB, Network Load Balancer for Layer 4. Google Cloud Load Balancer, Nginx, and HAProxy also support both modes. So, a load balancer is a specialized reverse proxy focused on distributing traffic for scale and reliability. Now, let's talk about API gateways. An API gateway also sits between clients and backends. It forwards requests. It can distribute traffic. So what makes it different? The purpose. A reverse proxy forwards traffic. A load balancer distributes traffic. An API gateway manages APIs, handling the cross-cutting concerns that come with exposing APIs to the outside world. But what that actually means: authentication and authorization. You have an API. Different clients have different access levels. Some endpoints are public, some require authentication, some are admin only. Without a gateway, every service needs to validate tokens, check permissions, reject bad requests. That's duplicated logic everywhere. With a gateway, authentication happens once at the edge. Invalid requests never reach your services. Your services just focus on business logic. Rate limiting. A client is hammering your API, maybe a bug in their code, maybe intentional abuse. Without protection, they could overwhelm your backend. The gateway enforces limits: 100 requests per minute for free tier, 1,000 for paid. Exceed the limit, request rejected at the edge. Backend never sees it. Request and response transformation. Your mobile app sends JSON. Your legacy service expects XML. Rather than rewriting the service, the gateway transforms the request format in transit. Or your backend returns sensitive internal fields. The gateway strips them before the response reaches the client. API versioning. You're releasing V2 of your user API, but existing clients depend on V1. The gateway routes V1/users to the old service, V2/users to the new one. Smooth migration, no breaking changes. Analytics and monitoring. The gateway sees all traffic. It can answer which endpoints are most used, what's the P95 latency, which clients generate the most errors. This data drives debugging, optimization, and capacity planning. This matters most in microservices architectures. You might have 20 services. Without a gateway, each implements its own auth, rate limiting, logging, inconsistently with duplicated effort. With a gateway, cross-cutting concerns live in one place. Services stay focused and simple. Common tools: Kong, AWS API Gateway, Apigee, Azure API Management, Tyke. An API gateway is an API-aware reverse proxy with features designed specifically for managing, securing, and monitoring APIs. So, if these are different things, why does everyone mix them up? Because real-world tools blur the lines. Nginx is a reverse proxy. It can also load balance. With plugins like OpenResty, it can handle rate limiting and basic auth, API gateway territory. Kong is an API gateway built on top of Nginx, so it's also doing reverse proxy and load balancing underneath. AWS sells ALB for load balancing and API Gateway for API management as separate products, but there's overlap. API Gateway distributes traffic internally, ALB can do content-based routing. You can picture these something like this. These aren't three boxes, they're a spectrum of capabilities. Left end, forward requests, terminate SSL, cache responses, core reverse proxy. Middle, add traffic distribution, health checks, failover, load balancer territory. Right end, add auth, rate limiting, transformation, analytics, API gateway. Different tools sit at different points. Some span the whole spectrum. The question isn't which category is this tool, it's which capabilities do I need? In real-world systems, you often use these layers together. Here's a typical setup. A request comes from a user's browser. First, it might hit a CDN, CloudFront, Cloudflare, Fastly. A CDN is a globally distributed reverse proxy, caching static content at edge locations, terminating SSL close to users, and absorbing traffic spikes. API requests then reach the API gateway. It validates the auth token, checks rate limits, and routes to the correct service based on the URL. Behind the gateway, a load balancer distributes traffic across multiple instances of each service and monitors their health. At the service level, Nginx might handle SSL for internal traffic and serve static assets. Each layer does something different. They're complementary, not redundant. But not every system needs all this. Simple web app with a few servers? A load balancer is enough. Public API with external developers and usage tiers? Add an API gateway. Match your architecture to your actual requirements. Quick decision framework. Multiple instances of a service, you need load balancing. Exposing APIs to external developers, consider an API gateway. Need auth or rate limiting before requests hit your services? API gateway. Just need SSL termination and caching? A reverse proxy like Nginx is straightforward. Often, it's a combination. API gateway at the edge, load balancers behind it, Nginx at individual services, each tool doing what it does best. To recap, a reverse proxy forwards requests, terminates SSL, caches responses. General purpose. Load balancer distributes traffic across servers for scale and availability. Specialized reverse proxy. API gateway manages APIs with auth, rate limiting, transformation, analytics. API-focused reverse proxy. They're not competing, they're layers, often working together. If this was useful, like and share. Thanks for watching. See you in the next one.